Good morning. It is Mrs. Bogus again with my Jimmy rigged cell phone setup. Wish I could take a picture of it, but I need my phone to take a picture of it. So we are working on another significance problem here. This one is talking about type 1 and type 2 errors. I apologize in advance if this is triggering for any of you. It is talking about COVID. A drug company has developed a new COVID vaccine. Woohoo! The company claims that fewer than 5% of adults who use its vaccine will get COVID. To test the claim, researchers give the vaccine to a random sample of 1,000 people. So we're doing three things here. We're stating the appropriate hypotheses. We're going to describe a type 1 and type 2 error in context and give the consequences. And then we're going to do a brief significance test. I wouldn't ask you to do all four steps for this particular problem. So, A, state appropriate hypotheses for testing the company's claim. So I am going to say I have a null hypothesis and I have an alternative hypothesis. So my null hypothesis here, remember that my null hypothesis is always going to be equals. So here I've got P is equal to 0.05. And my alternative hypothesis is that fewer than 5% of adults will get COVID. So P is less than 0.05. And P is going to be equal to the proportion of adults who get COVID. Now our P hat here is, okay, so LOL, I didn't even change. I changed this problem. It was about the flu. I changed it to be COVID to be relevant, but as you can see, I missed something, so that's okay. So part B is asking us to describe a type 1 and type 2 error and give the consequences. So a type 1 error would be if we reject the null hypothesis. Okay, if we reject the null, but the null is actually true. So type 1 would be if we conclude that the proportion is equal to 0.05 when it is really less. A consequence here could be that the vaccine doesn't get distributed because people don't think it's good. And I'm just going to abbreviate to BC because that's where I'm at this morning. So the vaccine would not be distributed because people don't think it works. A type 2 error would be we conclude less than 5% of people get COVID with the vaccine. But that is not true. In this case, it'd be higher, or it would be 5%. A consequence here is that people are getting sick. So people get sick when they don't think they will. Womp womp. So in this particular situation, I think a type 2 error would be worse because as someone who has received part of the vaccine already, like I'm assuming that it's working, and if I find out that it doesn't, like that's annoying. So that would be, in my opinion, worse. Sorry, I just took a coffee break. So Part C is saying of the 1,000 adults who were given the vaccine, 43 got the flu, where in this case I wanted to talk about COVID. So did these data provide convincing evidence to support the company's claim? So I'm just gonna run just the do part of my test, the do and conclude. There's no need to check all the conditions at this time. So my p hat here, the statistic we have is 43 over 1,000, which is 0.043. And that supports our alternative hypothesis. So that's a good first start. So my test statistic is going to be 0.043 minus my claim, so I'm going to calculate this out. I'm going to show you, right? I'm seeing here, this is what we claim, right? We claim that the proportion is right at 0.05. So we want to see how far, if this claim is true, what is the probability of getting the result that we got just by chance? So my standard deviation is very small because my sample size was large. It's actually 0.0069. Okay, so the plot thickens here. We are looking at about, we might have a standard or a z-score right about 1. Yeah, it's like right at -1. 1.01, if I'm being precise. And so a z-score or a test statistic of -0 or 1.0001 would be right at about 0.1562. So my p-value, 0.1562. Okay. So what that is saying is, and I'm going to put 0.43 right about here. If this claim is true, if only 5% of adults get COVID, then the sample that we got could potentially happen about 15% of the time, okay? So if we are using a 5% significance level, we would actually fail to reject the null hypothesis. It might be true that it's still at 5%. So does this data provide convincing evidence? I would say no. Our p-value of 0.1562 is greater than alpha at 0.05, and it'd even be greater than alpha at 0.1. So there's that. So we fail to reject the null. Again, I will post this, and if you have any questions, reach out. Have a great day.